So, hello everybody. I think you can see me right now. Welcome to the second Yocto live coding session in the wonderful year of 2020. This is also the very first live coding session that is not exactly focused on pure Yocto content, more like a little bit getting into the surroundings of application development with the Yocto project. Having said that, we're always grateful for good ideas, questions, topic suggestions that you can just shoot us right through Twitter, through LinkedIn, not through Stack Overflow, please. And the absolutely most favored ways would be either the mailing lists or #Yocto on freenode.org. If you scroll right down there on the Yocto Twitch page, then you will find some links. If you are viewing through my personal Twitch channel, then it's a little bit more complicated, unfortunately. But I think as you are all using Yocto to do crazy stuff like embedded Linux development, you'll totally figure it out. Remember to follow us, remember to watch what we've done so far, and I think it's time to start. What are we gonna do today? We're gonna do a very superficial but explanatory trip through getting started with a really simple Hello World-like application in C or C++, and starting out with a really just a C file, and then gradually progressing through why you actually want a build system and how this build system is meant to be working together with open embedded technology, and how a recipe for it should be constructed so that things actually work if you're not just doing like your magic on your personal desktop, but really doing this for cross compilation and deploying onto a target. Hopefully, here is a terminal and time to get started. Again, please join the chat, and uh, even if it's just for saying hello, drop in, type stuff like I totally am in love with your beard, and just to let us know that you're around. Okay, here we go. The first thing you totally need if you're gonna write write an app is a directory, and that directory is hopefully like named after the thing that you're going to write. And as I have no clue what we are gonna do with our application, let's just call it no clue, because I have no clue. Okay, no clue. What is the next thing? You need a source file. I'm gonna write something. Shall we call it main or shall we call it no clue? I think we gotta call it no clue. No clue. Okay, here's already the first really complicated thing in computing, naming things. We could just stick with C. We could call it CPP. We could call it CXX, or even a CC, which is the classic ending for C++ files. I'm gonna go with CPP just because I like CPP. Okay, what is no clue supposed to do? It's got to output that I totally have no clue. For outputting in C++, you usually use the IOStream. C++ also gets upset if you do void main void. It doesn't like that. So we're gonna do like int main void. Okay, and we gotta output std cout. You totally have no clue. Gonna end the string. std handle. Okay, I think our application is able to do this without errors, so we return 0. Sounds good to me. Okay, and here we go. GCC no clue. Oh, oops. And okay, I admit I knew that this would happen because I intentionally used GCC, and you can see a whole lot of undefined reference things, and those are a classic example or a classic error if you want to compile C++ files with GCC or with GCC or Clang without explicitly setting the language to C++. We could do that, but the usual way is to just switch over to G++. And okay, this doesn't give us an error. If we look around right now, then we have an A out, which is the canonical output name for C++ application. And if I run it, then it tells me that I have no clue, which is totally correct. But why does an A out have to tell this me? Because A out doesn't sound that it tells me that I have no clue. So we should just call it no clue. Let's get rid of the A out. And the output shall be named no clue. Okay, hooray! This is like the Yocto live coding equivalent of a C++ Hello World application. It's telling us that we have no clue. I think that's already not that bad. Okay, you can already see that I had to add some stuff to the invocation. In that case, it's like not that much. It's GCC, the sources, and one option. I think we can usually do this. Okay, let's add some more stuff. No clues, CPP. Can I have a short report on if the font is readable and the quality is high enough, because I kind of messed this up last time. I am speaking loud, clear, and understandable, and I'm just as awesome as ever, okay? If there's problems, just let me know quickly. I don't promise to figure it out, just so and I properly messed up again. Okay. Let's int argv character pointer argc. Let me get the command line arguments. And I gotta add something in here, which is just totally not error proof, but hopefully it's fine enough for the purpose of this demonstration. argc 1. Sounds good to me. Compilation. And of course I forget an header. Which is in stdlib. Include cstdlib and std. So hopefully that's it. Okay. No clue. I 3 times have totally no clue. That's quite impressive. to be to be clueless in this type of extent. So far, you see, I could add some library calls without adding up stuff to the compiler invocation. I could just now add another source file, which I would have to add, but I think you can figure this out for yourself. So, but I think it should not just tell me how many times. I have no clue. It really should tell me that I have even way more times no clue. So we're gonna get CMath, and we pipe this in. std. I think power is cool. Yeah. Wrong brackets. Compilation. I actually would have expected a problem right now. And I have 27 times no clue. I really would have expected that I get an error by now, which I didn't get. This is positive in a way that no errors are better than errors usually, but it's not what I wanted to show you. But anyways, we'll go on. Okay, so I could, no, we're doing good on time. So you see that I just used, no, this is, okay, wrong line of explanations. Pause, rewind, forget the last 3 minutes of what I just mumbled. Okay, if we would add additional source files right now, I would have to line them up all on the command line invocation, which is like meh. And if I wanted to link against non-standard libraries, I would have to add compiler flags like L something, or things that and this becomes complicated, and this becomes like hard to reproduce for anybody else who looks at your code and goes like, how do I compile this? So people invented makefiles. I'm not gonna show you a makefile because like makefiles are super old school, and this is the official reason. The unofficial reason is that I just don't have the syntax in my brains, and I really can't write a makefile. I have no idea how this works. So, but makefile syntax is complicated, and only weirdos and old gray-bearded Unix wizards love them. Everybody else was like, woohoo! There's another thing we can script, and everybody started inventing his, her, and whatever's own build system. So there was a time when every project had its own little super cool build system, which is just like worse than anything else. But the general concept of having a build system is not that bad after all. So the notion of a build system in place is something that really stuck, and you totally should use one if you are doing C or C++ development. For the sake of this live coding session, I'm gonna stick with CMake because it's one of the well-knowns today and the one that I personally happen to use. You could also go like for AutoTools or for Meson. Meson is like the cool kid on the block these days. Systemd uses it, for example, as far as I know, and it's just like I don't have any incentive to switch over from CMake, so I'm just gonna stick with it for today. Okay, what's the point about build systems? How do they work? You stick some form of configuration next to your sources, and the build system then parses all this and magically does all the magic that you need to properly build this. Okay, CMake. Let's get started with CMake. I hope that you would love it, Marco. So CMake list text, and now I gotta peek a bit into my notes, because I don't have the syntax on my brains also, but it's not as obscure as AutoTools, if you ask me. Okay, CMake minimum required is as far as I know not not canonically needed, but it also doesn't hurt. 2.8 because it's already quite old school, but I think you can build back to Krogoth with it. Project, no clue. We totally have no clue. Okay, and what are we gonna do? We gotta build an executable, and we're gonna call it no clue. And it consists of no clue, CPP. Hooray! That sounds sensible. And we got an add and install. Yeah, you will later see why this is actually necessary. When we're going to the target, we gotta install no clue to destination bin. There's similar Hello World examples for Meson and other tools. They're pretty much all alike. So really nothing super special here. It's just I happen to use CMake. Okay, and now CMake. CMake here. Unknown mode target. Ah, typo. Target. Okay. And you can see now that CMake actually gave us a make file. I think that's cool. I just wrote 4 lines that are not exactly like plain spoken English, but let me get them up on the screen again. You can pretty much guess what they mean. You specify that CMake has a minimum version. You specify how your project is called. You specify what you gotta compile, and you specify what is going to be installed in the end. And then you get a makefile. For entertainment, let's look at the makefile, okay? Feels good that I didn't have to type it myself. Great. Okay, make. My CMake generated makefiles have the neat side effect of giving me percentage outputs and colored lines. And come on, how can one not love like a pink output line in Bash? I mean, that's awesome, right? Everybody needs pink output. And you can see that there is no clue, and it did get core dumped, which I don't like that much. Really, no clue. Probably that is the error that I actually expected. Ah, no, not the error. I have to give it a number. Okay, 8 to I is like not that safe for misuse that it's supposed to be, but Marco, I don't have the stream really on screen, the chat really on screen all the time, but you saw the arrow instantly. So anybody, if you have got CMake questions, ask Marco, okay? So I think it's 20 minutes in, and we already have like milestone 1, create an application that uses a build system. Why the build system is really necessary is when you go into cross compilation. Everything that we did up to this point happened on the development host. So I wanted to compile it there. I wanted to run it there. And now if I wanted to cross compile to run on an ARM target, for example, I would have to have the toolchain installed, obviously, and I would have to manually specify it. The prefix and like arm dash gnu dash linux arm dash linux dash gnu eabi, I think it is, or whatever. And by the problems I have with remembering that, you can already imagine how hard it is to document and reproduce this at all. So this is where they intersect, or the whole system made up of BitBake or Yocto Project and the build system starts to shine, because we're gonna get over to my build. I have prepared core image minimal. Let's just be sure it is up to date. And while we kick off our first build, it's obviously time for today's beer. You can't do live coding without having a beer. Marco, this time you're almost right. This applies if you are specifically building for Pocky. Marco said that that the full compiler name is like arm-pocky-linux-gnu, GNU, whatever. You know what I mean. Which is correct if you're building for Pocky. It's actually Arch distribution ABI, and uh, if you're like using the cross toolchain that comes from the Ubuntu repositories, then there's no Pocky inside because it's a generic ARM for Linux toolchain. That's why I left it out. But in the Pocky context, you're right. Okay, and now up for some super cool magic. We to build no clue for our image, we gotta write a recipe for it. Writing recipes is not exactly fun. I have heard rumors that somebody actually likes it. I just haven't met that person yet, but I think there is somebody. Okay, well, what are we gonna do? Gonna do devtool add, and let's see if that works with relative paths. We're gonna find out. DevTool add, no clue. Time to drink. We always have time to drink. And DevTool tells us that it has been automatically created. I already have done a session on some DevTool in and outs, so this is just gonna be a very superficial look at it, at least for now. We're doing neat on time. Oh, I don't have VI. I can't edit in there, which is okay. DevTool works in the workspace that it sticks into the build directory. So we're just gonna go right there for the time being. If you have noticed, I did all the editing right on the real host while I'm building inside a Docker container. I kind of like skimmed over this, but the point is that the build host I'm using is a little bit outdated, and especially with the jump to Pocky to Python 3, I'm running into troubles, and that's why I'm just building everything in containers these days. Okay, uh, build workspace recipes, and there is no clue. And we gotta look at no clue. Okay, the command lines are not exactly optimal, but you can see the important parts are that it inherits CMake and nothing else. So here's where the magic starts to happen. We have bitbag classes for all the popular build systems, especially AutoTools, CMake, Meson, and some not so popular ones too, but don't use them. Use one of those three, okay? And if you don't do obscure things, so if you stick to the canonical way of doing things within your build system, then everything will just work. This is really an important thing to memorize. If you don't do anything super clever, don't do like, oh, I can do it just like in this 100 lines because I'm so super clever, instead of just using the one line that already came with it. Don't do it. It's not better. It will give you headaches when you're cross compiling. So if you just do things like they're meant in that build system, you'll be fine. I did stick to the canonical install. That's one of the core parts, and a project. Hence, everything CMake has to know about my project is there. And as CMake can properly handle it, bitbag can handle CMake properly. So all I really have basically really need to have in my recipe is inherit CMake. And therefore, we hopefully can do right now bitbake no clue. Fingers crossed, beer in hand. Something broke. Okay, what did break? Okay, that's because my directory is not clean. For demonstration purposes, I built in there. That's not super clever. We just need to get rid of everything that is not either my real source. I should have, now that I remember it, I should have given no same dir to let's start over. DevTool reset no clue. Let's do it right. That's a better approach than just hacking around. One thing to take away is you should make sure that your source directories are clear or clean. And we got an add devtool add no same dir, which means do the build in a separate directory. And if you can build in a separate directory, that's usually also a good sign. Okay. Shall we look again at the recipe? I think we can. Do, do you realize that I got rid of the terminal bell? It's awesome. Okay, it looks the same. Bitbake, no clue. Bitbake runs off. If I didn't have CMake built already, then there's another cool thing that would happen right now. The fact that I need CMake to do all the magic of the build would be detected by CMake BB class, and therefore Bitbake would take care to actually prepare CMake so it can be used for my build, which is cool. Use build systems, use them, really, even when you're drunk. Okay, I think we should look at the actual output of the build for a second, and then let's try and see the cross-compiled no clue in action. Okay, I think I've already explained the ins and outs of temp a little, so I'm just gonna skip to no clue for right now. Recipe sysroot, we can see that in, no, that's not what I meant. I meant package, user, bin, no clue. That's what we expected, exactly. And I'm gonna look at temp for a second, log to compile, for example, which now you can see what is really happening under the hood if C code is cross-compiled for your target. Here is where it starts. This is just the command line to G++ to make sure it's not some form of toolchain that happens to be installed on your dev machine. It's really the one toolchain that is meant for this cross-compile. It gets architecture, binary flags, ABI, some error messages. It gets the sysroot. You can see here sysroot starting to the sysroot of this recipe. Bitbake creates a sysroot specifically for each and every recipe being built. So you can detect if you accidentally link against a library that you don't have in your depends or whatever. This is super awesome. O2 and G are like clear, and then there's some additional flags for debugging, and hopefully somewhere, if I'm not totally mistaken, is actually the source file. Here you go. And I tried to get to the point where you understand that typing arcane compiler lines is bad. I just had a short example like G++ and O and L something, but this is like the command line that you need if you do cross compile seriously. And this is not something you want to write. This is something you want to automate. And here it comes again. Use your build system properly. Okay? Speak along with me. It's like the second Yocto chant. The one Yocto chant is Recipe data is local, conf data is global, and the second Yocto chant is use your build system properly. Okay, I'll put it on Twitter so you don't forget it. And okay, do compile finished. And there's another one I want to look at. It's do install, which hopefully shows me one very specific line, namely that it calls the install script created by CMake. This is also like a good thing. You don't want to write an application in a way that it can't be installed or that it can be tested only in the target but not in a development host or in a simulated environment or whatever. Make sure your build system provides a proper install routine, because if the install routine is also again in the canonical form, then Bitbake can split the packages without you needing to take care. This is what happened here. Everything ends up in the canonical path, so I don't have to do like a split into debug or headers or anything at all myself. Bitbake can handle it because I relied on canonical things instead of inventing my own. Okay, I think that's it for the praise of build systems. And what's the things we have to do right now? We need to add it to the build, or it won't end up in our image. Core image extra install is no clue. Bitbake core image minimal. I know this is like pretty introductory stuff for many folks who might be listening, but during the last couple of months, I've run into folks who get stuck over things like that. Where do I handle my linker flags? Where do I handle my compile line? Where do I handle how do these things act and work together if you're doing embedded Linux development? And that's why I was like, okay, this is something I should present on. Why not image install append? Because image install append would be parsed in the last stage. I think I remembered the reason once, but I forgot it. As far as I know, the rule of thumb is image install and image install append should go into recipe files, whereas if you want to just do a quick tinker in local.conf, you go for core image extra install because it gets injected directly through core-image.bb class, and I think the evaluation order also matters here. If the image explicitly sets image install to empty and only refers to a package group, maybe I don't know what would happen. I just know that if I'm in a configuration setting, and especially in one that I want to use for ad hoc testing, then I go for core image extra install. Bian could probably explain it much better. Yep, the final result is um, in the common case it's the same. There are fringe cases where core image extra install works as expected and image install does not. But tend to forget them. Okay, here's another. Okay, our image did build. Run QEMU. It's time for run QEMU. We're building for QEMU ARM just to make sure that the cross-compile process is completely working and in effect. And I just learned like yesterday that if I go for slurp as the networking, then I don't need to do the sudo tune tap dance, which is awesome if you're in Docker. And I just gave this a try, and I was like, oh my god, I'm an idiot. Why didn't I discover this earlier? It's awesome. It's like it just works. Okay, you cannot ping over it, but besides that, it's awesome. No graphic, slurp is like the one way to run QEMU. Okay. And here comes our image. It gets up. I can sing something again. This is um, the part in the session where I just babble my way out of things. And okay, here it is. It's I actually intend to do no more boots in this session. So which? No clue. User bin, no clue. So my image doesn't even only tell me that I have no clue. It also tells me where I have no clue. At which path. Okay, no clue. 3. Oh, I mistyped and I have like 32,786 times no clue. This is unintentional but pretty cool, right? If you have like 2 to the power of 15? Is it 2 to the power of 15 times no clue? I mean, like that's super geeky. And Marco is the only guy in the chat. Ain't there anybody else? I just think about what I could promise you to say hello in the chat. I could promise you free beer, but you're never gonna get it because I can't like hand it out through the webcam. I can announce something and it will be that you write and it will be around forever on YouTube. This is your chance to make a wedding announcement. Like nobody. Okay, no wedding announcements in my live coding sessions. Then some advertising. Follow us on Twitter, on LinkedIn, on YouTube, and on every other platform that you can find. Okay, just make sure that the Yocto project is going to rule the world. So, um, this is what I have planned for the content of this session. Yesterday, I've had a discussion on IRC on how to use the SDK. And as we have some time left for today, I think we should give it a try. Bitbake C populate SDK for core image minimal. This SDK should actually be enough to do the cross compilation dance without going through Bitbake. I totally did not try this. So if either the SDK creation takes too long or if I mess up somewhere during the process, then you're not gonna see it in the video. This can happen. I have messed up many times before. think I also should turn on the lights. It's getting dark outside here. Doop, 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 doop. 600 processes, 600 tasks left. That's quite a bit. Okay, I'm gonna talk about what I actually expect this to be like. The SDK always refers to a specific image. So as I have explicitly invoked popular SDK for core image minimal, the installable SDK that I'm supposed to get will contain a compiler that can target this image as well as a sysroot to bringing all the libraries I also have on that image, plus an environment setup script that does enough magic so the CMake on my host can properly cross-compile. Those are the three essential things in the SDK. And I hopefully can try this. But it now runs off and starts compiling bin utils, and if it starts to cross-compile GCC, we might be kind of like watching BitBake for some time now. The server I'm on is pretty beefy, but not sure it will get it done in the time that I have words to fill. Shall we? What shall we do? Shall we do some real library detection stuff with CMake? Marco, do you have an idea about a library call that we can use for demonstrating package config or such? Do you have something on your mind? Something that is available on a classic Linux rootfs, but needs manual detection and invocation. I thought LM would do the trick. That's why I opted for POW and thought and curses. Let me just have a look. And curses. I just want a really simple and curses example. Curses and clear. What do you think? Is clear enough for it to break if the library is not there? It hopefully should be. Let's give it a try. So, one no clue CPP include curses H. I happen to know that it is installed on my dev machine. Clear. Oh, no clue. No reference to clear. That's already pretty cool. Okay. Well, curses. Thanks, Marco. That did the trick. Okay. Here's what I just did. I added the header of a library that I need to switch on the light. I'm getting. Oh, I feel enlightened. Okay, here's what I just did. I added the header of a library that I happen to know that it is installed. But the header obviously only carries the definition. And where is the implementation? It's in a library that is somewhere on my development host. The development host, so I can use the implementation. I have to give a linker flag to the to the compiler, or to be precise, to the linker. And when I do the invocation manually, like this, then the L curses does this. Let's do a proper out of tree build through CMake dash dash, and here it comes again. CMake doesn't know, it has to search and ask for the library. And that's what I actually wanted to show you earlier. You have to tell CMake or whatever build system that you're going to use that you want to link against a library. So I've just like Googled this, and CMake should be able to do this if I CMake lists. If I go like C, I find curses. Hopefully. I think I'm just messing up big time right now. The internets tell me of course. This is the other really important thing. Learn how to Google. CMake find curses example. This is really not what I wanted to know. So while the example for a linker flag was good, Marco, I think the demonstration of it in CMake might be problematic for me being an idiot, and no good reason, of course. And the SDK is taking its time too. So we got some more minutes for sorting things out with CMake until I really have to end it. Actually, I would have expected it to be like this. CMake list text that okay. See, usually CMake works like this. You tell it that you need a specific package, in this case curses, and you require it. It doesn't work without it. And you need to add the resulting include directories, and I need to add the resulting link library, which should go like this. Target link library. I need to target no clue. Let's go through it one more time. I need to find cursors. This results in a couple of variables being set, namely the cursors includer, which I have to add to include directories, and the cursors library I have to add to the link libraries. This might sound a bit obscure right now, if I actually could only like add an L in cursors, but really the key point is that it also works when you're cross-compiling. So I have no clue again, and it did build. The GCC, the SDK is taking its time. Sorry, this was a bad idea. I know it. But at least, thanks to Marco, I got around to explaining the linker flags thing, which is probably better than me. Targeting drivers, yeah. Here it is, also in the chat. For those of you who monitor the chat, Marco also posted it again. So, this now the time is over, and my beer also almost is. Any other questions, ideas, topics, remarks, praise for my beard? If not, please remember to follow me, Lito at Readers the Second on Twitch. Say hello to us on #Yocto on Freenode. I'm usually around there. I go by the nick of Lito the Second there. Follow the Yocto Project on Twitch and Twitter. Spread the goodness. Be excellent to each other. Have lots of beer. And one additional announcement: we are applying for the Google Summer of Code, the GSOC, this year, and if we are actually accepted as an organization or project, then you can expect me to probably do like an introduction for those interested in the next week or the week after next week. So like not exactly live coding session, but hello, welcome, and what we are. Let's hope that things work out this way. Okay, and with that, let's yeah. Thanks for watching, everybody. Follow us on YouTube also. I usually try and monitor YouTube for comments. Besides that, everybody have an awesome evening and lots of fun coding stuff. Bye bye.